Hello and welcome to this video tutorial for the Space Combat Kit for Unity, where I'll be showing you how to set up the flight controls for a space fighter. So I've got a quick scene here with the player and a space fighter, and what I'm going to do is go over which components are used for the input and which components on the vehicle are used to move the ship around and steer it around in the scene. So on the player, as we covered in the last video, there's a lot of different input scripts which extend the vehicle input base class, and they can be shared among different vehicles that share functionality with each other. And one of the scripts that you'll find here is the player space vehicle flight controls script. So this script is an input script for controlling the space fighter. It can be used for space vehicles in general, not the capital ship because that needs a different kind of control setup. But basically for a lot of different types of ships, this input script will do fine. So this script extends the vehicle input base class, which we covered in the vehicle input video. But basically, as you might remember, vehicle input scripts have an initialize method where they look for the components on the vehicle that they need to send input to and make sure they're there so that they can work properly. So if we take a look at the initialize method of this player space vehicle flight control script, you'll see that the component it looks for here is the vehicle engines 3D component, which is a script for moving a vehicle around and steering it around in 3D. So let's take a look at what the vehicle engines 3D script is all about. So if we go to the space fighter, what you'll see here is a script called Powered Vehicle Engines 3D. Now this is a script that extends the Vehicle Engines 3D class, so it will be found by the input script. And basically it just has additional settings for if you've got a power component on the vehicle, which we do over here. We'll cover it in a different video, but basically you've got some additional settings for the power here. So let's go over the inspector settings real quick and take a look at what you can do with them. So we have the controls disabled checkbox, which can be used to disable the controls temporarily if you want the ship to if you want to take control of the ship or make it go in a particular direction and don't want the player input. We have the option to activate the engines at the start, which is set to true. Now that enables you to have a sort of ignition on-off of the engines, as you might see in these other scripts. We've got the jet exhaust visual effects controller, which is basically visual effects for this vehicle engines 3D component. That's visual effects, and we've got the sound effects over here, engine sound effects controller. And basically, if the engine is activated, you'll see on the animation curve for the sound effects that there's some volume here, even when the throttle is at 0. So basically it enables you to switch on the engines, but you're not going anywhere, but there's still some sound effects coming from it. And the same thing on the visual effects controller. You'll see there's a bit of a visual effect even when the throttle is at 0, as long as the engine is activated. Let's continue. So in the current settings, what it basically lets you do is set the movement and steering input values in the inspector, just in case you want something to happen when the scene starts. These values are changed by the input script, so if for any reason you just want to start the scene with the ship moving around or turning, you can do that here. And basically the inputs, what these are values from -1 to 1. So these control the amount of input for each axis of steering and movement and boost. So for example, steering, the x-axis is the pitch, that's nose up and down. So basically, -1 to 1 values here will make the nose go up and down. And you've got the same thing for the y-axis rotation, which is yaw. So you've got rotating around the y-axis. So you send input from -1 to 1, and then you've got the roll as well. Basically, that's the steering input from -1 to 1 to rotate around each axis. The movement inputs, same kind of thing. One, for example, on the x-axis will go that way, -1 is that way. The y-axis, so 1 is up, -1 is down, and movement is 1 forward and -1 backward. So it controls the amount and not the actual force on the vehicle, which we'll cover in the rest of this inspector. So the boost inputs are the same kind of thing. It's basically boost -1 to 1. You probably won't be using the X and Y axis boost, probably just Z 0 to 1 forwards. And so basically to boost forward at full boost, you just put that to 1. So the input limits, that basically, these min-max movement inputs basically limit how much input can be sent for the movement on the x-axis, y-axis, and z-axis. So -1 to 1 on the x-axis means that it'll be able to move equally on each side there. -1 to 1 on the y-axis means that it'll be able to go from full input up to full input down. But if on the z-axis, you'll see that the minimum is -0.1, so we don't want the ship to be able to move backwards very fast at all. So we've limited that value, the maximum negative input, if you like, for the z-axis. And we can go full speed forward. So the default forces, these are basically if you're not using power, because power will determine the forces on the vehicle, how much power you've got sent to the engines, if you've got that installed. But if you're just using the vehicle engines 3D, which doesn't have anything to do with power, then these default forces will determine how fast the ship turns and moves in the game. So, for example, we have default movement forces. So that's the add force. So basically, these values are the forces applied to the rigid body when the input is 1, or -200, for example, if the input is -1. So it's basically the input multiplied by these forces to get the force on the rigid body, the force applied to the ship. So you can see that we can move a little bit faster forwards and backwards than we can move left and right or up and down. And default steering forces, that's the same kind of thing. So we have the input for the steering going from -1 to 1, and that's multiplied by these forces on each axis to get the force, the torque, which is rotational force, applied to the ship. And you'll see that it can roll a lot faster than it can pitch. And the default boost forces are basically the forces applied during boost, and in this setting here, apply movement forces during boost means that if you tick that, then the movement force plus the boost force is what's applied when you press the boost input, whatever key that is. Basically, this limits the amount of force that can be applied to the ship. So that's the force applied to make the ship go left and right, up and down, forwards and backwards. These are the limits. So even if you're using power, the power available to the engines is multiplied by these values to get the forces. They'll still be clamped inside these limits over here. So just in case the player dumps all the power to the engines, for example, you might not want the ship to go zipping around too much, so you might just set these limits here to have an upper limit on how fast the ship can move. And then you've got the power settings on the Powered Vehicle Engines 3D script, and this is the reference to the power component, which we've got here. And the power to rotation force coefficients basically tells you the amount of power available to the engine is multiplied by this value here to get the rotation force around the x-axis, the maximum rotation force around the x-axis, which is then clamped inside these limits as well. And that's the same for the y and z rotation axis, and then the same thing for the movement translation. So the power available to the engines is multiplied by this value to get the maximum force that can be applied to the ship to go left and right, up and down, and forwards and backwards. That covers the Vehicle Engines 3D component, or in this case the Powered Vehicle Engines 3D component, which is kind of the integral spaceship controller script in this kit, which you'll probably be using for most of your vehicles. Even the capital ship uses this script. It's a pretty versatile script for moving and steering a vehicle around in 3D. So let's take a quick look at the player. The input script for this Vehicle Engines 3D. So you've got the vehicle input settings here, which we covered in the vehicle input video. We won't go into them again. Then you've got the control scheme, the link, yaw, and roll setting. This is like for the Starlancer game. It basically enables you to control yaw and roll with one input. So if you've got like a touch joystick, for example, which only has 2 axes of movement, you can control 3 axes of rotation. And how that works is basically when you're rolling the ship, instead of rolling on a point, you'll add yaw, so the nose will trace out kind of a circle, which the size of which is determined by the yaw roll ratio. So with that, you can kind of move the ship to point in any direction without too much trouble, using just 2 input axes. Mouse steering enabled, so when that's checked, the ship will steer around based on the mouse position on the screen. So when you move the cursor out to the left, it'll make the ship steer left, and so on. Mouse vertical inverted, so that means that if that's checked, then if you bring the cursor up, it'll make the nose go down, and vice versa. Mouse pitch, yaw, and roll sensitivity, that basically determines how much the ship rotates on each axis based on the mouse position. So if you've got a very high sensitivity there, then you only need to move the cursor out from the center of the screen a little bit, and then you'll be rotating the ship very fast. And a low sensitivity, then you need to bring the cursor out a long distance to make the ship rotate. So the mouse dead radius is basically the fraction of the viewport, which goes from 0 to 1, up and down and left and right on your screen. and it's the amount, basically the amount of the screen that the mouse position won't affect the vehicle steering. So, for example, if you don't want if you want the ship to be able to just kind of stay on the same heading, even when you move the mouse around a little bit around the center, then you can set that with a dead radius over here. So keyboard steering, same kind of thing. Vertical inverted means that pressing up will make the nose go down and vice versa. And steering enabled means that you've got keyboard steering happening. So under that, we've got a bunch of custom input for setting the flight controls input. So these are custom input settings, so you can really set whatever you want the input to be in the inspector. So this uses the input manager as we covered in the input video, and you can pretty much configure the controls however you like in the inspector. So for the pitch, which is nose up and down, we've got the vertical axis. Yaw, left and right nose, is the horizontal axis, and roll is the roll axis. And then we've got all the throttle inputs, so Z is going to up the throttle, X is going to make decrease the throttle, and then we've got axis values for moving forwards and backwards, strafing vertically and strafing horizontally. Then we've got the throttle sensitivity, so it means how fast the throttle moves up and down when you're pressing these throttle up and throttle down keys, and the boost. So when you press tab, you'll boost. So that covers it for the space vehicle flight control script, which is a flexible script for controlling the vehicle engines 3D in a space fighter-like array. The capital ship uses a different kind of control because the look around is controlled by the mouse, and then you've got the keyboard used to move the ship around. So I will cover that in a different video, but yeah, for pretty much any space fight or most kinds of spaceships in your game, you'll probably just need this space vehicle flight controls working with the vehicle engines 3D script on the ship. So that's pretty much it for this video. Thanks for watching, and I'll see you in the next one.